Hello again, Math 200 students. We're on section 5.3, still on normal distributions, which is what the whole chapter 5 is about. This time we're finding values. So before we were finding z-scores or finding percentages, but this time we're going to be given a z-score, we're given a percentage, and finding the value associated with that. I want to say one thing. As you're doing your homework, if the problem says find the value in the normal table or whatever, you can do it that way if you want to, but you don't have to do it the way that the problem says. You can do it the way I've been showing you, which is in your calculator. All right, in section 5.2, you were given a normally distributed random variable x, and you found the probability that x would lie in an interval by calculating the area under the normal curve for the interval. But what if you're given the probability and want to find the value? So it's like you're saying, so here's the difference. You might say, what's the probability that a man's shoe size is less than 8? Okay, then you do what we did in the previous sections. You would put negative 1e99 for the lower. You'd put 8 for the upper, and this is all in the normal CDF. And you'd put the mean and the standard deviation and calculate the probability that way. But what if the problem instead said something like, what shoe size do 75% of men have a shoe size less than that shoe size? Then that's what we're doing in this section. Let me maybe make it a better example. What test score do you need to make to be better than 95% of the population? Like, what IQ do you need to have to be in the top 5%? That would be a question that we're trying to answer in this section. All right. So example 1, find the z-score that corresponds to a cumulative area of 0.3632. All right, we're not being asked to find an area or a percentage or a probability. This time we're given an area and we're asked to find the score or the data point associated with that area. So we go to second distributions. And we don't go to normal CDF, we go to the inverse normal. So we're kind of doing the opposite of what the normal CDF does. We're going to inverse normal, option 3. Okay, the area that we're looking for, let me draw this for you. All right, because you need to see it, because if they gave you the area is 0.3632, okay? That means this area right here is 0.3632, or 36% of the area. And you're trying to find what is this value that has that area. So that means you're looking for this is called a left tail. A left tail. And that's telling you the value here that has that much area to the left of it, or less than that. You could have also done a right tail. What if we want to know what value has 0.3632 of the data to the right of it, or more than that, and we're looking for that value? That's called a right tail. Okay, and then another way is, another problem might ask, what two values have 80% of the data between those two values? And that's called, let me see what it's called on the calculator. I think it's called center tail maybe. Yeah, it's just called center, or center tail. So you gotta think about what the problem is asking. If it's talking about being to the left or less than something, It's left tail if it's talking about being to the right or more than something. It's a right tail if it's talking about being between two things. It's a center tail. So going back to our problem, let's read it again. Find the z-score that corresponds to a cumulative area of 0.3632. And remember, cumulative area means all the area that has accumulated up to that point, meaning all the area to the left of that. So this is a left tail. So the area is 0.3632. The mean, since it says z-score, it's talking about a standard normal distribution. Z-score is standard normal. Z-score and standard normal means that the mean is 0 and the standard deviation is 1. So if it doesn't give you a mean or a standard deviation and it just says z-score or standard normal, then you have your mean given to you just by definition, that the mean is 0 and the standard deviation is 1. So we can go ahead and go to paste and get our answer. The answer is that the z-score associated with that area, with that cumulative area, is negative 0.3499, or we might say negative 0.35. So a z-score of negative 0.35 or 0.35 standard deviations to the left of the mean has about 36% of the data to the left of it. Find the z-score that has 10.75% of the distribution's area to its right. All right. Again, the inverse normal makes this a pretty easy thing to do. Option 3. We're looking for 10.75%. You got to put this as a decimal, 0.1075. Don't put 10.75. Put the decimal. 10.75% is 0.1075. Still talking about a z-score, so the mean is still 0 and the standard deviation is still 1. But this time it says to the right of it. So we're not doing a left tail, we're doing a right tail. And we go down to paste. And we get that answer is 1.2399, or about 1.24. So a z-score of 1.24 would have only 10.75% of the data more than that, or to the right of it. So a z-score of 1.24 would almost be in the top 10%. Almost, not quite though. Moving to the next page. All right, let's do percentiles. In section 2.5, you learned that percentiles divide a data set into 100 equal parts. To find the z-score that corresponds to a percentile, you can use the standard normal table. We don't have to use the standard normal table, but we can use our calculator. Recall that if a value x represents the 83rd percentile, then you can represent that by this, P83, P subscript 83. Then 83% of the data values are below x, and 17% of the data values are above x. So if you want to find P5, that means that 5% of the data are below that P5. So we can go, it says find the z-score associated with P5. So go to second distributions, inverse normal. P5 means 5%. But as a decimal, that's not 5, it's 0.05. 5%, P5 is 0.05. The mean, since we're talking about a z-score, is still 1. The standard deviation is still, it's still 0. The standard deviation is still 1. We're talking about 5% of the data being to the left of that thing. So we're doing a left tail. And we calculate our answer. So a z-score of negative 1.6449 is what we're looking for. Let me show you that you could have also done this a different way. We could have done the area as 95% because that's the complement, isn't it? 0.95. And we could have not done a left tail but a right tail. We should get the same answer if we say what value has 5% of the data to the left of it. We should get the same answer if we ask what value has 95% of the data to the right of it. We should get the exact same answer. So we can do this one with a right tail, and we should get the exact same answer, and we do. So I hope that gives you a feel for what is going on here in the calculator and the left and right tails and all that kind of stuff. Find P50. Well, we don't even have to calculate P50. 50% of the data are to the left of what z-score? 50% of the data are to the left of the mean. And the mean would have a z-score of 0. 0 z-score means you're on the mean. So P50 would be 0. P90. Okay. Inverse normal. P90. So I'm going to do the area being 0.9 or 0.90. And I'm going to do a left tail. I could have also done 10% or 0.1 and then a right tail, and it would give me the same thing. But P90 means I'm doing a left tail. I'm finding the value that has 90% of the data to the left of it, and it's 1.28. So a z-score of 1.28 is more than 90% of the data. In other words, it's in the top 10% of z-scores. All right. Transforming a z-score to an x value. Okay, we don't have to know this very much, but I'm going to show you how to do it anyway. It's just algebra. So if you've got x and you've got the mean and you've got sigma, you just do the calculation and you get z. But what if instead of you having x, they give you z and the mean of the standard deviation, you have to find x? That means you're going to do a little bit of algebra here. Let me do that. Let's say you know z and you're looking for x. You get an x by itself. We're solving for x. That means we're going to get x by itself. So the first thing we do is get rid of the sigma here by multiplying both sides by sigma. That gets rid of that sigma. So I've got z sigma equals x minus mu. Then we want to get rid of the mu. Well, we just add mu to both sides. And that gives us x. So z sigma plus mu equals x. So now the formula is solved in terms of finding x. So you can just multiply z times the standard deviation and then add the mean, and that'll give you the x value associated with that z-score for any particular data set. That's what they have here. All right, so finding an x value corresponding to a z-score. A veterinarian records the weight of cats treated at a clinic. The weights are normally distributed with a mean of 9 pounds and a standard deviation of 2 pounds. Find the weights x corresponding to the z-scores of 1.96, negative 0.44, and 0. So you just do 1.96 times sigma, which is 2, plus the mean, which is 9. And that gives you 12.92. And that's what you do for each of those. And that's nothing to it. Now, this one, the what weight would correspond to a z-score of 0, we don't even have to calculate that. That's going to be the mean. The mean always has a z-score of 0. So the mean is 9. So 9 would be the value corresponding to the z-score of 0. Next page. You can also use the normal distribution to find a specific data value, x value, for a given probability. Okay, scores for the California Peace Officer Standards and Training Test are normally distributed with a mean of 50 and a standard deviation of 10. An agency will only hire applicants with scores in the top 10%. What is the lowest score an applicant can earn and still be eligible to be hired by the agency? In other words, what score is the 90th percentile? What score has 90% of the data lower than that score? Or you could say it like this. What score is the bottom of the top 10%? We have a mean, we have a standard deviation, and we can do either a left tail with 0.9 of the data, 0.9 or 90% of the data, or we could do a right tail with 0.1, which would be 10% of the data to the right. So left tail with 90% or right tail with 10%, either way you do it's fine. Just go to inverse normal. I'm going to do the area being 0.9 since that's already there. This time the mean is not, we're not talking about a z-score or standard normal. We're talking about, we're given just a real world type of mean and standard deviation. So the mean it told me was 50 and the standard deviation was 10. And I did this as a left tail. If I'd have done 0.1, it would have been a right tail. They would have to score 62.8 or more to be in that top 10%. 62.8 would be the minimum score that they could score to still be a candidate to be hired by that particular agency. Again, I'm giving you kind of the simplest way to do these. If you click on help me solve this or whatever in Math Excel on these problems, it's going to give you a way to do it, but it's not going to be as simple as the way that I've explained to you here. So if you want to use the way they're telling you, no problem, go right ahead. No problem with that whatsoever. But just know that it's not going to be the same thing that I'm telling you in these videos. And what I'm telling you in these videos is a little simpler and shorter. Nothing wrong with doing either method. All right, finding a specific data value. In a randomly selected sample of women aged 20 to 34, the mean total cholesterol level is 181 milligrams per deciliter, with a standard deviation of 37.6 milligrams per deciliter. Assume the total cholesterol levels are normally distributed. Find the highest total cholesterol level a woman in this age group can have and still be in the bottom 1%. So, and that's a good thing to be in the bottom 1% of cholesterol levels, right? Because you want low cholesterol. So what's the highest cholesterol you can have and still be in the bottom 1%? I got to try to remember. My mean is 181. My standard deviation is 37.6. If I forget that, one of you guys remind me. Just speak through the video and remind me. Yeah, right. If I was in class, you could. The area is the bottom 1%, so 0.01. I want 1% to be to the left of me. The mean, I can't remember. I think it's 137 or 134. No, 181. I wasn't even close. 181 and 37.6. 181 and 37.6. And I am doing it as a left tail. If I'd have done 0.99, I could have done that and done a right tail. So my cholesterol level to be in the bottom 1% would need to be at the most 93.5. Okay. And that is it. Notice they're using standard normal tables and all that kind of stuff. The answer we get is actually better than the answer that they get. So if they get 93.39 and we got, what did we get? 93.53. Our answer is more spot on. It's more accurate than the answer that they're getting from using the tables. All right, and that's it for section 5 point whatever section. I think 5.3 is what we just finished. So I'll see you again. Good luck on that assignment. I'll see you again in 5.4.